Hello, good morning, ladies and gentlemen. Today we are going to be learning about the Earth Science Reference Table, Igneous Rock Identification Scheme. This is going to be on page number 6. So go ahead and take out your Earth Science Reference Table if you haven't, and let's rock and roll with this. All right, now that you have your Earth Science Reference Table out, let's do justice to this. This chart is really kind of a little bit complicated, but I trust you guys will be able to make a killing out of it. The first thing is I want you to observe is that this area represents all the igneous rock that this chart is talking about. So these are the names of the various igneous rock that we're going to be looking at, or any research questions would reflect on. Okay, to the left is the environment of formation. All right, igneous rock are formed in different environments. Okay, some of them are formed inside the earth, some of them are formed outside the earth. To make it a little bit clearer, I have this picture here. Now, this picture here just shows you the intrusive igneous rock, which means these are rocks that are formed inside the earth. These rocks did not make it to the earth's surface. While on the other hand, you have the extrusive igneous rock right here. Now, these are rocks that made it to the Earth's surface. So this rock, they come in contact with air, they come in contact with the Earth's surface. As a result, they cool down fast. Okay, and some of them interact with the air. And as a result of their interaction with the air in the atmosphere, they have gas pockets, like pumice, for example. Okay, so gas pockets, rocks with gas pocket would look something like this. So you see that rock with those little bubbles all around? That is called gas pocket or vesicular. Okay, so when you come across the word vesicular or gas pockets, those are the things, or this is the kind of picture you should have in your mind. An igneous rock having gas bubbles all over. So it is extrusive igneous rock that have those kind of features because they came in contact with air, or they made it to the Earth's surface and they cool down really fast, while intrusive igneous rock cool down really slow. And as a result of their slow cooling, they were able to grow crystals. Okay, so let's head back to the ESRT. So that is that for the environment of formation. All right, to the right, you have crystal size, which tells you about the size of the crystals that you can find in the igneous rock. So when igneous rock are being produced, they form crystals inside. So this tells you the size of the crystal. If the size of the crystal is so small, we say it's non-crystalline, which means it did not form any crystal at all. So as a result of no crystals, that kind of igneous rock would be glassy when you look at it. All right, to give you a pictorial view of it, here's what a glassy igneous rock would look like, just like a glass. All right, moving forward, further to the left, to the right hand side is the texture, and we just threw some light on that. So by now you know what vesicular means and what non-vesicular would mean. Vesicular means it has gas pockets, non-vesicular means it does not have gas pockets. And then if the crystals are very small, we say that rock is fine because it's just less than 1 mm. If the crystals are big, like you have here, ranging to 10 mm, then we say that that rock is coarse. And then if the crystals are very large, which means 10 mm and above, then that rock is very, very coarse. That's it. Okay, next is, besides reading this chart horizontally, you can also read it vertically. On the vertical side, we have the felsic rock. Okay, so when a rock is felsic, it means it is lighter in complexion or in color, and then it has a lower density. When you read this word here, density, and then you draw that arrow, you see it is lower in density, and then it's felsic, which means it's rich in silicon and aluminum. Then to the right side are the rocks that are darker, okay, and then they are higher in density and they are mafic, which means they contain iron and magnesium, right? Then if you continue reading downward, it tells you about the mineral composition. Now, it is minerals that come together to form rocks. So when you read this graph down, for instance, let's take this rock, rhyolite. Rhyolite
contains potassium feldspar because I can see it right there. If I continue reading it down, it touches quartz, so which means rhyolite also has quartz in it. And then you continue to read it vertically, you see it has this mineral as well, which is pyroglycase feldspar. And then you continue reading it down straightward, it has biotite. And then lastly, it has amphibole. So this is how you're going to be using the this earth science reference table in answering different reagent questions. All right, let's make it easier. Let's take another example. Let's take a popular rock such as basalt. Okay, basalt right here. We can see here that it was formed in the extrusive environment, which means basalt made it to the Earth's surface. So as a result of making it to the Earth's surface, it cooled down really fast. So as a result of that fast cooling, it didn't have enough time to grow crystals, to have big crystals. So as a result, it has a very fine texture, all right? And then it can be vesicular. At the same time, it may not be vesicular as well. Then in terms of mineral composition, we see that it has pyroglycase feldspar. We continue to draw the line straight up. It contains pyroxene, and then you can see if you follow the broken line, it also touches this little guy here, biotite, which means that very little percent of biotite. And then you continue downward, you see it has pyroxene, and then it also has olivine, and then lastly amphibole right there. So that is how you're going to be using the ESRT page 6 of the Earth Science reference table. Some unique rocks here, like peridotite right here, only has 2 minerals. So when you read it downward, it only has this mineral, pyroxene, and then you continue reading it downward, it has olivine. So it only has 2 minerals. Dunite, on the other hand, which is the last mineral here, dunite only has 1 mineral. If you read it vertically, looking at that downward, you see it only has 1 mineral. That kind of mineral, that kind of rock is said to be monomineralic, which means it has only 1 mineral. All right, best of luck with your practice. See you on the outside. Bye for now.